Hello, and welcome to this film, which is about oxidation numbers. It's the first in a series of films about redox chemistry, a series of films that looks like it's been filmed with me sort of coming into land, upside down. Um, the second of these films, slightly strangely, is about the definitions of some key terms. The reason I haven't dealt with those first is because quite a lot of them refer back to oxidation numbers, so I thought it might be an idea to go through these first. Now, hopefully by the end of this film, you'll be able to assign an oxidation number to an atom. So you'll be able to look at a formula, whether that's for an element, a compound, or an ion, and you'll be able to decide what oxidation numbers the atoms in that formula have. Okay, we'll have a quick look at something which you don't really have to explain in exams, and that is what is an oxidation number. People sometimes think of it as being exactly like a charge, which it is if you're dealing with monatomic ions, but if you're not, then it's not. It's quite useful, I suppose, for certainly covalent molecular substances where there aren't any formal charges. Oxidation number gives us an idea of whether an atom has lost or gained electrons compared to its neutral atom. Okay, as I say, it's not an important thing to be able to explain. It is important to be able to write it down, though. So if I was asked what's the oxidation number of calcium in a calcium ion, so there's a calcium ion, I'd say that its oxidation number is +2. Okay, and if I was asked about the oxidation number of oxygen in an oxide ion, then its oxidation number would be -2. Now it's not always that simple, but what I really wanted to point out here was that with a charge you write the number first and then the charge. With an oxidation number you write the plus or the minus first, which isn't always a charge, and then the number. Okay, so in actually assigning these, a little bit of maths is involved, but it's really very simple, addition and subtraction, so it's nothing to be scared of. There's a few rules we need to follow. Here are the first two. They're the simplest rules, not that the others are particularly hard. The first of these rules is that elements are always given an oxidation number of 0. So sodium has an oxidation number of 0. Nitrogen atoms in nitrogen molecules also have an oxidation number of 0. Any element I choose to mention will have an oxidation number of 0. Okay? Monatomic ions, so that is ions that are made of only one atom, and notice this is an ion, it's not an element anymore, okay, even though it's made of an element. Sodium ions have an oxidation number of +1 because their charge is +1. Okay? Nitrogen, which forms a nitride ion, okay, a monatomic ion made of nitrogen has a 3- charge, so its oxidation number is -3. Okay, so for a monatomic ion, that is an ion that's made of only one atom, the charge is the same as the oxidation number. That is to say, it equals the oxidation number. And for elements, oxidation numbers are 0. The other rules are a little bit more complicated, but really not very hard at all. They deal with compounds and they deal with ions. Okay, we'll start with compounds. Now, in a neutrally charged compound, and all compounds will be neutrally charged, the sum of oxidation numbers has to be 0. So if I took carbon dioxide, the carbon atom's oxidation numbers and the oxygen's oxidation numbers would all have to add up to 0. I'm going to use these two rules here. These are the most commonly used and most commonly stated rules, even though there are exceptions to them. There's also these two rules, which we'll use in a moment. These aren't so commonly stated, but there aren't any exceptions, so I sometimes wonder why they're not the first ones that we learn. But these, I guess, are a bit more useful because they come up in more compounds that we look at in this course. So anyway, using these two rules, if oxygen is usually -2, then I've got two atoms with an oxidation number of -2 here. So the carbon, if I was asked what's the oxidation number of carbon in carbon dioxide, I'd say +4. Okay, because carbon's oxidation number has to add up with these oxidation numbers to make 0. If I was asked what's the oxidation number of nitrogen in ammonia, I'd use this rule here, that hydrogen is usually +1. And I've got 3 of them here, so 3 +1s. The nitrogen, if these oxidation numbers are going to add up to 0, has to be -3. Okay, now group 1 will always be +1, group 2 will always be +2. For example, in sodium oxide, the sodium ion will have a +1 oxidation number. There's two of them, so they're both +1. And oxygen is -2. Now that might not strike you as being unusual because you know this rule already, but we'll see something in a moment called a peroxide, where this rule about oxygen doesn't apply. But we'll deal with the exceptions to the hydrogen rule. Now, hydrogen forms compounds called metal hydrides. So some metals are so good at giving away their electrons that hydrogen will actually take them from the metal. And in this case, sodium, which is always +1, will be +1. What's the oxidation number of hydrogen in sodium hydride? It must be -1. So if you're looking at a metal hydride, hydrogen can have something other than +1, and that will be -1. Okay. Also, if we look at things called peroxides, so hydrogen peroxide is an example of one of these. You could also look at potassium peroxide. Okay. Now this has an O2 2- ion, and if we look at what an O2 2- ion has, well, the oxidation numbers have to add up to -2, so each oxygen is going to be -1. Okay, and that's what is the case for all peroxides. Okay, we've got oxygen with an oxidation number of -1 as opposed to its usual -2. So in this case, hydrogen sticks to the rule of +1 +1. Okay, we've got two of them, so it's both +1. All these oxidation numbers add up to 0, so oxygen must be -1. So in any peroxide, oxygen will be -1. Now in ions, rather like here, the sum of the oxidation numbers will equal the charge on the ion. Okay, so let's just go through a couple of examples of these. Let's start with, let's start with a nitrate ion, just to show you something about nitrogen, that it doesn't always have the same oxidation number. Now this isn't a peroxide and it's not a metal hydride, so we're going to stick to the rules. So oxygen is -2. I've got three of them. 3 times -2. All these oxidation numbers have to add up to -1. So in that case, the nitrogen here must have an oxidation number of +5. Let's have a look at maybe an ammonium ion. Okay, NH4+. Hydrogen is always +1 except for in metal hydrides. This isn't a metal hydride, so I've got 4 times +1. All these oxidation numbers add up to +1, so nitrogen here again must be -3. Okay, there are actually other oxidation numbers that nitrogen can have, but I'll have a look at those some other time when you do some problems. Just very quickly to look at something that has a compound that has ions in it, maybe sodium carbonate. Okay, and maybe a different one that doesn't have a metal who I've got a rule for, so maybe let's go for copper sulfate. Okay, now looking at the oxidation numbers in these compounds, they're neutrally charged overall. So if I said what is the oxidation number of carbon here, I could use my group 1 rule and go, well, I've got +1 and +1 for the sodiums, and I've got 3 times -2 for the oxygens. And all these oxidation numbers add up to 0, so the carbon must be +4. You can just stop and figure that out if you need to. Okay, or I could say to myself, well, I've got a carbonate ion here, which is a CO3 2- ion. My 3 -2s for the oxygens, and the carbon have to add up to -2. So again, carbon is +4. So two different ways of dealing with that. I could be asked the oxidation numbers of the elements in this substance. I think if you're asked the copper, then the simplest way is to remember that this is a sulfate ion and therefore has a 2- charge. So this must be a copper 2+ ion. So the oxidation number of copper here must be +2. Once you've decided that, you could go on to work out the sulfur's oxidation number, or you could just deal with it as a sulfate ion. It really is up to you. You should get the same answer both ways, because we've got 4 -2s for the oxygen, 4 times -2, and a +2. All have to add up to 0, because this is the compound, so sulfur here must be plus 6. Likewise here, if I've got 4 minus 2's and they add up to minus 2, then sulfur is plus 6. Okay, that's about it for oxidation numbers. Hopefully it's not too tough, but it'll be worth looking back through your notes and checking that they make sense to you. If there's anything that you want to ask questions about, please come and do that as soon as possible. It's better that you get these problems sorted out now rather than later on in the topic, because a lot of this redox topic depends on an understanding of oxidation numbers. So yeah, as I say, the next film, it's all about definitions of terms, but if you want to ask questions about oxidation numbers, please come and ask as soon as you can.